Dear students, in this session we are going to discuss more on multiple access schemes. Multiple access schemes are used to allow many mobile users to share simultaneously a finite amount of a radio spectrum. Multiple access is a technique that lets multiple mobile users share the allotted spectrum in the most effective manner. In computer networks and telecommunications, the multiple access method permits various terminals to connect to the same multi-point transmission medium to transmit over it and share its capacity. Please see the outline for today's presentation. We'll be discussing about multiple access techniques. Then it's also important to know the difference between multiple access techniques and multiplexing. Then we will be discussing the types of multiple access techniques. Multiple access just means many can access at one time, while multiplexing is a process to combine multiple signals for transmitted over a single channel or media. Generally, multiplexing combines several low-speed signals for transmission over a single high-speed connection. The image presented here actually demonstrates how multiple access techniques are applied in mobile and wireless communications. So in wireless communication systems, it is often desirable to allow the subscriber to send information simultaneously from the mobile station to the base station while receiving information from the base station to the mobile station. A cellular system divides any given area into cells where a mobile unit in each cell communicates with a base station. The main aim in the cellular system design is to be able to increase the capacity of the channel, that is, to handle as many calls as possible in a given bandwidth with a sufficient level of quality of service. Now, it is very important for us to appreciate the difference between multiple access techniques and multiplexing. Both multiplexing and multiple access methods have a threefold purpose. Number one, allowing multiple users to share finite communications resources equally and efficiently with acceptable mutual disturbance. The main resource shared is the transmission medium, which has a few degrees of freedom such as space, frequency, spreading code, time, and power. When the aggregation of channels is done before the modulation process, it is known as multiplexing. When several independent stations access a medium, the term multiple access is applied. A well-known example of multiple access is Ethernet LANs, where all nodes have access to the same medium. Time division multiplexing, abbreviated as TDM, is a method of transmitting and receiving independent signals over a common signal path by means of synchronized switches at each end of the transmission line so that each signal appears on the line only a fraction of time in an alternating pattern. Here you will be seeing the graphical animation for the time division multiplexing. Time division multiplexing is a method of putting multiple data streams in a single signal by separating the signal into many segments, each having a very short duration. Each individual data stream is reassembled at the receiving end based on the timing. The circuit that combines signals at the source end of communications link is known as a multiplexer. It accepts the input from each individual end user, breaks each signal into segments, and assigns the segments into the composite signal in a rotating repeating sequence. The composite signal thus contains data from multiple senders. At the other end of the long distance cable, the individual signals are separated out by means of circuit called a demultiplexer and routed to the proper end users. A two-way communication circuit requires a multiplexer, demultiplexer at each end of the long distance high bandwidth cable. Similarly, you can also observe how frequency division multiplexing works. In frequency division multiplexing (FDM), the available bandwidth of a communications channel is shared among multiple users by frequency translating or modulating each of the individual users onto a different carrier frequency. Multiple access techniques permit multiple access to a channel. A channel represents a system resource assigned to a given mobile user that enables the user to establish communication with other users in the network. Depending on the channel type, specific multiple access technique can be used for communication. Depending on how the available bandwidth is allocated to the users, these techniques can be classified as narrowband and wideband systems. Systems operating with channels substantially narrower than the coherence bandwidth are called as narrowband systems. Narrowband TDMA allows users to use the same channel but allocates a unique time slot to each user on the channel, thus separating a small number of users in time on a single channel. In wideband systems, the transmission bandwidth of a single channel is much larger than the coherence bandwidth of the channel. Thus, multipath fading doesn't greatly affect the received signal within the wideband channel, and frequency selective fades occur only in a small fraction of the signal bandwidth. In this slide, you will be seeing a video clip that illustrates the types of multiple access.
All of us get excited when we see the symbol. But how does it work? Ever wondered how millions of subscribers are served by telecom operators simultaneously? Hi everyone. Welcome to the world of long-term evolution. Today we will show how multiple users access network using multiplexing.
In the last video we have shown how two signals were combined over a common pathway in duplexing. So, what exactly is multiplexing? Multiplexing is the process of combining multiple signals and transmitting them over a common channel. Then what is multiple access? When multiplexing is used to allow multiple users to communicate over a single common channel, we call it multiple access. In other words, multiple access is nothing but the application of multiplexing. So here's a Wi-Fi hotspot sharing its internet connection among multiple users by providing them a frequency block over which they can transmit and receive data. The greater the size of this block, greater is the throughput. Telecommunication systems, which mostly use radio waves as a communication link with end users, have employed several ways to share this resource.
FDMA, which uses frequency division multiplexing, provides chunks of the frequency spectrum to each user for data transmission. Generally, the data is generated at baseband and modulated at varying radio frequencies. Guard bands are introduced to avoid any interference. AMPS, or the first generation analog systems, used FDMA to provide each user a duplex channel with one-way bandwidth of 30 kHz. TDMA, which uses time division multiplexing, allows multiple users to share a common frequency band by allocating different time slots. Thus, in an N-channel TDMA, where each channel is given a time slot of 2 seconds, signals coming from each user will be transmitted at intervals of N into T seconds. This technology was used in the 2G systems like GSM, GPRS and EDGE. Each user was provided one of 8 TDMA slots in a bandwidth of 200 kHz. Dynamic resource allocation meant more users could be supported, but each channel could support only 8 active users at a time. CDMA, based on code division multiplexing, is a technique in which the data bits are modulated by a high-frequency orthogonal sequence of bits such as Walsh codes or pseudo-random codes such as gold codes to spread the signals over a large frequency band. Multiple such signals from different users are then transmitted over the same frequency band. In order to retrieve the signal, receiver must have the same spreading sequence, which is multiplied to this composite signal in a process called despreading. This makes CDMA very secure and robust. It was used in 3GPP2 standards such as CDMA and CDMA Evolution Data Optimized standards. Wideband CDMA or WCDMA spreads the signals over an even higher bandwidth. This was used in the 3G standards of 3GPP from UMTS to HSPA+, where the available bandwidth was 5 MHz compared to 1.25 MHz used in CDMA. There are other multiple access techniques like wavelength division multiple access, which is used in fiber optics, and space division multiple access, which refers to spectrum reuse over non-overlapping areas.
As the number of users and their demand started growing, communication networks evolved from 1G to 4G. Radio part was significantly enhanced from GSM to HSPA+. Now, focus was shifted towards better spectral efficiency by using higher modulation order like QPSK, 8PSK, 16 com, 64 com, etc. WCDMA improved upon some of the problems of earlier generations like, first, low data rates. In GSM, effective bandwidth for a user was only 25 kHz. Second, congestion at peak hours, as the frequency chunks and time slots were very limited. Third, resource wastage. Resources remained idle when users were inactive. Fourth, poor spectral efficiency, due to guard bands and guard periods used for avoid interference. But, exhaustion of spectrum, need for even higher data rates, and spectral efficiency lead us towards OFDMA. OFDMA comes with several advantages over WCDMA like bandwidth scalability, carrier aggregation, low intersymbol interference. OFDMA uses orthogonal subcarriers equally spaced at 15 kHz. Users are provided a subset of these subcarriers for data transmission. Unlike FDMA or TDMA, OFDMA allows the users to access variable bandwidth depending upon the resource availability. Also, since these subcarriers are orthogonal, there are no guard bands between them. It was first introduced in Wi-Fi, and subsequently in WiMAX, by IEEE, but as WiMAX lacked backward compatibility and support for mobile wireless at its inception, operators remained stuck with WCDMA. This changed with the introduction of LTE, which brought OFDMA to the forefront of today's mobile networks.
So, today we showed what were the different multiple access techniques that were used in various generations of wireless communication. In our next video, we will dive deep into OFDMA and SCFDMA, the two pillars of 4G.
With this, we come to an end of this session on multiple access. Now I want you to post the answers for the activity in the discussion forum. You can see the questions in this projection. Once you have submitted your responses, you may leave. Thank you for listening. Let's meet in the next session. Bye for now.